And you're watching this beautiful YouTube channel Physics Analysis. So let's get this started. Prove that spherical mirror in plane mirror, right? So this is one of the question we have. So the question is prove that spherical mirror formula is applicable, right, equally in plane mirror also. Of course, see what is mirror formula? Solution I am showing you. Mirror formula is, we have mirror formula. What we have? 1 by f is equal to 1 by v plus 1 by u, where f is focal length, v is image distance, u is object distance, right? And we know about the characteristics of image formed under plane mirror. We are going to prove that this mirror formula is valid in plane mirror, in case of plane mirror also. So what should be your approach? See, for a plane mirror, है ना, for a plane mirror, r is equal to radius of curvature is equal to infinity. Why? Because if this is the plane mirror, you see radius of curvature means what? What do you mean by radius? The radius of that hollow sphere of which mirror forms a part. So you do you think the curve it is a part of curve? If it is, then the radius will be infinite. So radius is infinity. So at the same time, focal length will be 2r by 2, twice of focal length, that is r is equal, f is equal to r by 2, r is equal to twice of f. So if r is infinity, the focal length will also be infinity. So for a plane mirror, focal length is infinity. Now putting this value in equation, in the above equation. So the above equations becomes 1 by infinity is equal to 1 by v plus 1 by u. अब 1 by infinity means what, बच्चों? 1 by infinity means what? अच्छा, can I write infinity? Infinity means what? 1 by 0. So 1 by infinity means 1 by 0. So will you write 1 by infinity means 1 by 0 means 1 into 0 by 1. So definitely 0 by 1. So 0 by 1 is what? 0 by 1 is 0. So 1 by infinity means 0. 0 is equal to 1 by v plus 1 by u. Right? That means minus of 1 by v is equal to 1 by u, or else minus of 1 by v is equal to minus of 1 by u. Yes or no? So what we are having? V is equal to minus of u. V is equal to minus of. This is what exactly happened in plane mirror. So in plane mirror we have seen image is formed behind the mirror. Image is formed behind the mirror as the object in front of it. If it is 5 distance, image will also be 5 distance. We have read already. So and see, if it is positive, then this is negative, right? So here v is equal to minus of u. So yes, of course we can say that yes, this spherical mirror formula is applicable equally in plane mirror also. So this is one of the question, very beautiful question. Okay, तो आइए सेकंड क्वेश्चन देखते हैं. क्वेश्चन नंबर 2. The lower half reflecting surface is covered by is there concave mirror. concave mirror का जो reflecting surface है ना, half of the reflecting surface of concave mirror is covered. अब let us suppose this is a concave mirror, right? This is a concave mirror. You have seen all possible cases, image formed जो है in all possible cases, how the nature of image was differ in different cases, right? So one of the case I am taking just to make you understand, one of the case I am taking. So let us suppose one object is placed between somewhere C and F. This is the pole P, this is mm dash, this is this is the principal axis x dash. So let us assume one of the object placed, light ray coming from this object after reflection passing through focus. Now one image is being formed. Here image is being formed, right? You could have taken one more ray, like this is one of the ray. After reflection, this also will be meeting exactly at the same point, right? Just I am trying to make you understand that this object, from every point present in this object, जो है light is coming out of in all possible direction. Billions of light rays are coming out of every point present in this body, right? And even half of the portion is covered. Suppose up to here, this much portion is being covered. This much portion is covered. This much portion is covered. Then also for this object, this much portion is enough to form a complete image. You can see here. We are not using this part of reflection. See here, we are not using this reflecting surface area. We are using only this much reflecting surface area. Then also we are able to get full length of image. You can see here. This is the object. This is the image. Real, inverted, and magnified image. This is, I think, case number 4. This is case number 4. When the object is placed in between C and F, it's a real, inverted, and magnified image is formed. In fact, we can take one as many rays we will take here, from here, from here, from here. All these rays after reflection we formed. Now coming up to the question. The question is lower portion is covered. Okay. Then what will affect? See, effect to hoga. Why? Because now the reflecting surface area is reduced. So the brightness will also be reduced. Yes, that I admit, that I accept that the brightness, the intensity. However, the reflecting surface area is reduced, so the intensity of image is less, right? This is how you can approach for this question. Next question देखते हैं. Question number 3. A mirror is turned through 15 degree. A reflected ray turn. Did you understand the question? Hello. Well, the question is, a mirror is turned through 15 degree through what angle will the reflected ray turn. So let us suppose this is one of the mirror that is given to you, okay, mm dash, we can consider mm dash, and if this is the mirror and one light ray is incident, this is how one of the light ray is incident at point of incidence O, and if AO is the incident ray, then we have one of the normal, like this is the normal, ON is the normal, and this is the mirror. Now the question is, a mirror is turned through 15 degree. So without turning, what was the angle of incidence? This is the angle of incidence. In that case, angle of reflection will be like this. This is the angle of reflection. If this is angle of incidence, AON, then BON is the angle of reflection. Now, if the angle is turned by 15 degree, let us suppose what exactly happened when a mirror is turned. So let us assume, I am assuming that the mirror is turned by some angle theta. If this mirror is turned by theta, then you can say, sir, a normal will also be turned. So let us suppose now the ON was the normal on mm dash. So now after turning m dash, m double dash, the normal will become this n dash O. If it is theta, then this will also be theta, right? Now if AO was the incident ray on mm dash, for the same incident ray, the reflected ray will be different. I think somewhat like this. This is B dash. Now the question is, what is this angle BOB dash? What is this angle? For AOB dash, I can write AO n dash plus B dash O n dash. So that will be I plus theta plus R plus theta. For this I can write minus, for AON I will write I plus R. For BON I am taking R, BON. Now see, H per angle of incidence, H per laws of reflection of light, okay, angle of incidence is to be equal to angle of reflection. So that means IR, you can write this also I, and plus theta and plus theta. So theta plus theta 2 theta, or plus R I will write I, minus again I, or plus I in place of R I will write I is equals to R, H per law of reflection of light. So what we are having left with, this I plus I, 2I, again this I plus I, cancel out, right or not? This is 2I and this is again here. So what is left? 2 theta. Now if this angle is theta, right, then what angle, by what angle this angle will be changed? By twice of theta. यानी कि एंगल B dash OB, angle B dash OB will be twice of theta. This is your concept. Now coming to the question. The question is 15 degree and a mirror is turned through 15 degree. So if a mirror is turned through 15 degree, then this angle, the reflected ray, will be turned by 15 into 2, that is 30 degree. So this will be, if it is 15 degree, then this will be 30 degree. Okay, so the answer is 30 degree. Clear? आई होप यू अंडरस्टैंड। तो आइए नेक्स्ट क्वेश्चन देखते हैं। क्वेश्चन नंबर 4, नंबर ऑफ इमेज ऑफ एन ऑब्जेक्ट held between two parallel plane mirrors, right? So we have to find out number of images formed of an object when placed in between any two parallel lines. So plane mirror. So you know the number of images depends upon the angle of inclination, okay, of the mirrors. So if suppose two mirrors are placed and they are parallel to each other, then how many number of images would be formed? So number of images formed depending upon theta, and the equation we have number of images. For that we are getting the final number of images will be 360 by theta minus 1. Okay na, 360 by theta minus 1. So here theta will be can we assume 0 degree when this two mirror will be placed so close? Okay, of course it is parallel. So here theta will be 0 degree. If theta will be 0, then 360 by 0 or either minus 1 will be what? Infinity. So infinite number of images will be formed when an object, let us assume one of the object is there. So for this mirror, the image will be here. Again this image will be acting like a object for this mirror. So again mirror images will be like this. Again for this will become the object. So the next images will be like this. Again for this mirror, this is acting as a object, so the image will be like this. So like this will continuously the form. Okay, so many, like I am showing you like this, the images will be right. Again in this case the images will be like this. Again for this and this will so on continue. All right. So when the object is placed, let us suppose this is one of the object, an infinite number of images are being formed. You can see here n. Okay, if n is odd, if n is even, depending on that we are finding, but here theta will be 0. So you can use this equation. If n is equal to 360 by theta minus 1, already it is coming in infinity. So whether you add or subtract the outcomes will be infinity. All right na? Thank you so much. Next question लेते हैं. Question number 5. Can we obtain you can be asked you could be asked, okay, can we just obtain the image formed by a convex mirror on a screen? Very conceptual question, right? Here the question is image formed by convex mirror. So you know that image formed by convex mirror is virtual, erect, diminished. Okay, so image formed by convex mirror is virtual, and virtual image cannot be obtained on a screen. So if the question is can we obtain an image formed by convex mirror on a screen, the answer is big no, not at all. Why? Because image formed by convex mirror is virtual. Image formed by convex mirror is virtual, and virtual image cannot be obtained on a screen, right? Okay, so moving on to the next question, let us see. Question I am asking to you, you write in comment section, can a convex mirror form a magnified image? Tell. So this was just a question asked to you. Moving to the next question. Okay, next question is what are the power of what are the power and focal length of a plane mirror, right? Question number 7. What are the power and focal length of a प्लेन मिरर? तो आइए समझते हैं प्लेन मिरर की पावर और फोकल लेंथ. So this is the mirror you have, plane mirror. Okay, so you know a plane mirror has infinite curvature, so that means r equals to infinite. Obviously f will also be infinite because f is equal to r by 2. So if r is infinite, then f is also infinity. Now focal length is infinity, so p is equal to 1 by f, and 1 by f is 1 by infinity, so the power will be 0. So focal length is infinity but power is 0. Understood? What is the minimum size of a plane mirror? Which can enable a person to see his full size image. क्या लगता है भाई, कितना हो सकता है? Student might be thinking, sir, same size, sir, double. Na. Half is enough. Won't believe. See, I am showing you. Let us suppose this is the mirror. Okay, this is the mirror, and your height is this much. Your height, and this is the man height. Man height is double than the size of mirror. That means even a half mirror is suitable. Even a half size of mirror is suitable to get full length body image. Clear? And the question is, how can you distinguish between plane mirror, concave mirror, and convex mirror? Just by looking them. Let us see. Distinguish between plane mirror, यानी आपको टच नहीं करनी है. नो नीड टू टच. विदाउट टचिंग द मिरर यू हैव टू डिस्टिंग्विश वेदर द गिवन मिरर इज प्लेन मिरर, कनकेव मिरर, कॉन्वेक्स मिरर. कैसे करोगे? अब see, again I am taking one of the mirror, and let us suppose here you are. So without touching a mirror, how will you understand whether the given mirror is plane, concave, or convex? See, I will place myself in front of the mirror just as it is. Now if I observe the image formed by the given mirror is same size. I found same size, then the given mirror is plane. But if the size of my image is smaller, okay na, smaller by and by in further changing the position, like coming forward, coming backward after the mirror, we are seeing that my image is coming smaller in all possible cases. So the given mirror is convex. And if you see your image is little bigger, like you are getting a case, you are saying your image is bigger, right? So the given mirror is concave. And you see bigger size image is formed only in case of concave mirror. Clear? And this plane mirror, same size, convex mirror is smaller and concave mirror bigger. So this is how you can understand whether the given mirror is plane, concave or convex without touching to them. You just adjust yourself, keep yourself, place yourself in front of the mirror and you observe your image. If your image is same size, that means go for the plane mirror. If the image is smaller, then the given mirror is convex. If the image is bigger, little bigger, magnified, then you go for concave mirror. All right. Hello. So this is one of the question. Does the size of mirror affect the nature of image? Does the size of mirror affect the nature of image? No. Whether the mirror is smaller or bigger, still the mirror is capable to obtain full length of image. But one thing I can say, that a bigger size mirror has a bigger reflecting surface area, can give you more brightness. So yes, you will write no, except that bigger mirror gives brighter image. Clear? Next question पे आते हैं. A convex mirror is held under water. So what would be the change in focal length? You see, focal length of a mirror depends on radius of curvature, and radius of curvature जो है is independent to the medium. So whether a mirror is placed in water or air, its radius of curvature will be as it is. R is independent of the medium, of the external medium, then focal length will also be independent of the external medium, right? So if a mirror is placed in water, so what would be the change in focal length? No change. Whether the mirror is placed in water or air, focal length depends upon radius of curvature, and radius of curvature is independent of the medium, right? That's all.